Okay, in this video, we're going to be doing some radical operations. Now, let me explain something. That radicals work just like variables. 3x plus 4y, you can't add those. They're not like terms. So radicals are going to work the same way. You can only add or subtract radicals if they are like terms. So here we go. We'll explain that as we go. Step number one, simplify over the, this is adding, subtracting. Simplify the radicals just like we have been. Step number two, identify radicals with the same index and the same radicand. What does that mean? They're like terms. In this case, these were unlike terms. If they have the same index and the same radicand, and again, the radicand is the number under the radical. So right now, these two are not like terms. Only these can be combined. Step number three, for common radicand or radicals, add or subtract the coefficients and keep the common radical. Only the same way would look if this was 3x plus 4x. You add or subtract the coefficients and you get 7 and you keep the x, right? That works the exact same way. Number one, simplify first. So you have 3 times root 27 is root 9 times root 3 minus 2 times, I'm going to go ahead and do them both, root 12 is root 4 times root 3. I'm going to go ahead and on these problems, I'm going to start multiplying these together as I'm going to skip the step. 3 times root 9 is 3 times 3. That's 9 root 3 minus 2 times root 4 is 2 times 2, which is 4 root 3. So now look, these are now like terms. You have 9 root 3 minus 4 root 3, which is the same thing as having 9x minus 4x, which is 5x. So in this case, 9 root 3 minus 4 root 3 is 5 root 3. Number two, the 3 times the cube root of 54, we're going to split into the cube root of 27 and the cube root of 2, minus 2 times the cube root of 2, that's not going to clean up any, plus 7 times the cube root of negative 16. We're going to split into the cube root of negative 8 times the cube root of 2. Now let's clean it up. 3 times the cube root of 27 is 3 times 3, which is 9 cube root of 2, minus 2 cube root of 2, and then 7 times a cube root of negative 8 will be negative 2. Positive 7 times negative 2 will be negative 14 cube root of 2. Now, all three are like terms. Notice the index and the radicands are identical. So add or subtract the coefficients. 9 minus 2 is 7, minus 14 gives you negative 7, and everything else stays the same. Number 3. 4th root of 48, we're going to split. That'd be 7 times the 4th root of 16 times the 4th root of 3, minus 2 times the 4th root of 3, plus 3, and then 72, that would be, let's see, let's split that into, oh, I nearly messed up there. That's actually a 3rd root, and that's the reason I couldn't think of anything. A 3rd root of 72, let's split that into, let's see, 8 times 9. We know the cube root of 8. Okay, so now let's clean it up. 7 times the 4th root of 16. 4th root of 16 is 2. So 7 times 2 would be 14, 4th root of 3, minus 2 times the 4th root of 3. And these, again, can clean up. That's 3 times 3rd root of 8, or the cube root of 8 is 2. That's 3 times 2 is 6 times the cube root of 9. Okay, we have 2 like terms here. The index and the radicand are the same. 14 minus 2 gives me 12 times the 4th root of 3. However, this other one is not a like term with it. We cannot combine them unless they are like terms. Number 4, back to square roots. 10 times the square root of 28, we can split into root 4 times root 7. Plus the cube root of negative 56. Let's say the cube roots that we know, again, are 8 and 27, which is already too big. So let's split this into the cube root of negative 8. Let's go ahead and take that negative out, times the cube root of 7, minus 4 times, now we're back on square roots. I know the square root of 25 is inside of that 175, so let's split it into square root of 25 times 7. 10 times square root of 4 would be 2 root 7. The cube root of negative 8 is a negative 2, so you can think of this as a 1. Positive 1 times a negative 2 would be a negative 2 cube root of 7. And then negative 4 times 5 would be negative 20 square root of 7. Now, these look like they should all be combinable. They're not. These are square roots. This is a cube root. The index and the radicand has to be the same, so we can combine the 2 minus 20, which gives you negative 18 root 7, but do not combine it with the cube root. Number 5. Now we got some variables involved, so let's take these one at a time. The first one, root 98, root x to the fourth, root y to the second, and I'm going to do it first over here. Square root of 98 is 49 times 2. To take a square root, the exponents need to be even, so I actually know both of those. So I have a 7 here. Square root of x to the fourth is x squared. Square root of y to the second is y, and we're going to leave the 2 under the radical. Now the other one, let me change colors here. Well, it's already simplified. Minus 3x squared y root 2. Okay, now all of your variables and all of your radicals must be the same to be able to combine them. Look at your coefficients. If everything else is the same, then you can combine coefficients. X squared y root 2, x squared y root 2. So therefore, 7 minus 3 gives you 4 x squared y root 2's. Nothing else changes except for the coefficients. Next one, cube root of negative 40, a to the 7th. Remember, since we're taking a cube root, that what you split this into must be a multiple of 3. So we're going to do negative 40 will split into the cube root of negative 8 and the cube root of 5. I'm not going to rewrite it this time since we kind of getting to the point to where we know. Cube root of 8 to the 7th, the multiple of 3 would be a to the 6th, and we're going to split it in, therefore into a to the 6th and a. So we know this and we know this, so that'd be a negative 2. Cube root of a to the 6th would be a to the 2nd, and we're going to leave under the cube root the 5 and the a. This one and this one. Now let's move on to the other one. We have then plus, let me draw me a line until I get this finished. 2a squared, actually let's go ahead and simplify the cube root first. The cube root of 135a to the 4th. Let's see, I believe there's a 27 in there. So let's split this into the cube root of 27 times the cube root of 5. And this has to be a multiple of 3, so the cube root of a to the 3rd is the largest one, smaller than a to the 4th, and the a would stay. So that would be we know this and we know this. Let me write it up here. So we know the cube root of 27 is 3, the cube root of a to the 3rd is a, and underneath the cube root is the 5 and the a. Those two are staying. So now I can write my problem down. Let me come down to the very bottom, bring this down. Negative 2a squared times the cube root of 5a plus, the original problem has a 2a squared times 3a times the cube root of 5a. Now I've got an issue here. I've got to combine these. And that's going to give me negative 2a squared times the cube root of 5a plus the 2 times 3 is 6a to the 3rd times the cube root of 5a. Now, here's my coefficients, the negative 2 and the 6. In order to combine them, this stuff needs to be the same. And they nearly are except for the a squared versus a to the 3rd. So since those are not the same, that's as simple as we can get this thing. Okay, next up we're going to multiply radicals, and these are pretty simple. Step number 1, we're going to multiply coefficients, multiply numbers with numbers, and then we're going to multiply radicals with radicals. And the product rule says you can multiply radicals as long as they have the same index. The nth root of a times the nth root of b would be the nth root of a times b, so they can be combined. And then you simply simplify the resulting radical. Like here, root 27 times root 5 is the square root of 135. That's it. Just multiply 27 times 5 because they have the same index. Then we are going to try to simplify it. We're going to split it into root 9 times root 15, which will be 3 root 15. Next up, number 8. We're multiplying these, so multiply your numbers out front, because here, technically what you've got is 4 things being multiplied here. So multiply what you can. 3 times negative 2 is negative 6. Root 10 times root 18 is root 180. Then let's simplify. That's going to be negative 6, and let's split root 180 into root 36 times root 5. This will be negative 6 times 6, which is negative 36 root 5. Number 9. Now you're dealing with third roots. Multiply your coefficients because, again, you have 1, 2, 3, 4 things being multiplied together. That's it. So multiply 2 times 5 is 10 times the cube root. 9 times negative 24 is a negative 216, which you actually know the cube root of. 6 times 6 times 6 is 216, so therefore this would be 10 times negative 6, which is simply negative 60. Number 10, we're multiplying some fourth roots here. First, multiply the negative 3 times the negative 1, which is a positive 3, times the fourth root, 64 times 8, that'd be 512. Now, here's the thing, though. There's an issue here, and this brings up the concept of could you actually simplify before you multiply? And the answer is yes, because it was kind of simple, kind of silly to multiply those already. Because now when we go to split it, you know what we're going to split it into? Well, I know the fourth root of 64, so I'm going to split this into 64 times 8. So do you see that you actually went back to where you started? The fourth root of 64 here is 4. Okay, number 10, multiplying coefficients, negative 3 times, there's a negative 1 understood to be here. Negative 3 times negative 1 is 3. And then you have the fourth root of 64 times 8, which is a 512. Now we have to find something we know the fourth root of inside of that 512. Let's see, here's the things I know the fourth root of. I know the fourth root of 16, which is 2 to the fourth. 3 to the fourth is 81. 4 to the fourth is 256. And I think that would work because I actually see a 4 times 4 times 4 here, and then here's a 4 times 2. So do you see when you multiply those together, you actually have 4 fours. So that kind of gives you a hint of what you can multiply or what you can split it into. So fourth root of 256 and the fourth root of 2 would be at 3 times the fourth root of 256 is 4. So that's 3 times 4, which is 12 times the fourth root of 2. Okay, number 11. Multiply your coefficients, which is 1 times 5 is 5. And then you multiply your radicals. 6 times 8 is 48. X to the, count them, there are 9. And then let's simplify. You can bring down the 5 if you'd like, or you can just come over to the side and split the root 48x to the 9th. Let's see, I know the square root of 16, so let's split it into root 16 times root 3. And x to the 9th, it needs to be an even power, a multiple of 2, so we're going to split it into x to the 8th, that's the largest one, and x to the 1st. So we now have 5 times the square root of 16, which is 4, times the square root of x to the 8th, which was x to the 4th. And underneath the radical, I'm leaving the 3 and the x. So let's clean it up. That'd be 20x to the 4th times the square root of 3x. Number 12. It's a third root times a third root, no coefficients besides the 1, so we don't have to worry about the 1s. 54 times 5 is 270. M to the 8 and 4, count them, there are 12. So let's split it into, let's see, the cube root of 270, that'll be pretty simple. I can actually just do the cube root of 27 and the cube root of 10. And the cube root of m to the 12th, I know, so I can leave it as is. Cube root of 27 is 3. Cube root of m to the 12th is m to the 4th. And I'm leaving the cube root of 10 underneath. Number 13. Again, no coefficients, so I'm simply multiplying the radicals. You have a third root of negative 3 times 36 is negative 108. Count the a's, there are 13. Count the b's, there are 6. And I'm doing a third root, so I need multiples of 3. Let's split this into, let me make that smaller. Two numbers that multiply to give me 108 would be a negative 27 and a 4. And notice I left the negative on the one that I know the cube root of because I can do cube roots of negatives. A to the 13th, I need a multiple of 3, so I'm going to do a to the 12th, and I'm left over with just 1a. And then I know the cube root of b to the 6th because it's a multiple of 3. This one is negative 3. This one is a to the fourth. This one is b to the second. And I do not know these two, so I'm leaving underneath it times the cube root of a 4 and an a. There's your final answer. Number 14, you do have some coefficients here. 2 times 7 gives you 14 times the fourth root of, count your p's, p squared, p to the third to be p to the fifth. Count the q's, there are 11 of them. Let's split it into some things that I can do. I need multiples of 4 here, so I'm going to split it into p to the fourth and p to the first. That's the smallest multiple of 4, smaller than 5. Then over here, my 11, I'm going to split into the fourth root of q to the smallest multiple of 4 under 11 would be an 8. So an 8 and a 3. So we're going to leave the 14. Fourth root of p to the fourth would be p to the first. Fourth root of q to the eighth would be q to the second. And underneath the fourth root, I'm leaving the p and the q to the third. Okay, for the next part, I'm doing the same thing except for I'm using the distributive property and I'm foiling, so everything's basically the same. Now, I do want to point something out, just a reminder. If you ever multiply a square root times itself, you get the square root of 9, which is 3. If you multiply a square root times itself, which is the same thing as squaring a square root, they undo each other, and you're just going to get the number on the radical. Remember that as we go through these problems. So the first one, root 10 times both of these gives you a 5 root 50. You can only multiply the radicals with radicals, minus 2 root 20. Now let's clean those up. The root 50, I'm going to split into root 25 times root 2. And the root 20, I'm going to split into root 4 times root 5. 5 times root 25 will be 5 times 5, which is 25 root 2. And 2 times 2 is 4, so that's going to be minus 4 root 5, and those do not combine. Number 16, 8 times everything. 8 times 3 is 24. You cannot multiply 8 times negative root 10, so you leave it as negative 8 root 10. Negative root 10 times everything. Negative root 10 times 3 is a negative 3 root 10. And then a negative times a negative is a positive. A root times itself removes the radicals. Or root 10 times root 10 is root 100, which is 10. Combine your like terms. 24 combines with 10, which is 34. Negative 8 root 10 and negative 3 root 10 gives you negative 11 root 10. Reminds me a lot of multiplying together complex numbers. Number 17. Nearly have some conjugates here. So we're going to multiply 6 root 6 times both of these. 6 root 6 times root 6 will be 6 root 36, or when you multiply a radical times itself, it removes the radical, so that'd be 6 times 6 then. Plus 6 root 12 when you multiply the root 6 times the root 2. Now we got to multiply this times both. Negative 6 root 2 times root 6 would be negative 6 root 12, and then negative 6 root 2 times root 2 will be negative 6 times root 2 is just plain 2. When you multiply a square root times itself, it removes the radical. Now these you will not have to simplify because they're actually opposites of each other, so they're going to cancel anyway. And your final answer is going to be 36 minus 12, which is simply 24. Number 18. There's a shortcut for squaring a binomial. Here it is. Square the first number, multiply the two together, and double it. 4 times negative root 5 is negative 4 root 5. Double that gives you negative 8 root 5. Then multiply the last number times itself. Negative times negative is a positive. Root 5 times root 5 is 5. So there's your shortcut for squaring. Combine your like terms gives you 21 minus 8 root 5. It's great to know that shortcut. Distributive property again. Root 3k times both of these. Root 3k times root 12k would be root 36k squared. Minus 2 times the square root of 3 times 15 is 45. K times k squared is k to the third. Now let's try to simplify these. We know both of these square roots, so we can just do a 6 and a k. Minus 2 times the square root of 45, I'm going to break into the square root of 9 times the square root of 5. Square root of k to the third, I'm splitting into the highest even power, which is k squared, or the multiple of 2 times the square root of k. Now let's clean that up. Bring down your 6k. Let's see, I can I can multiply these. That's 2 times 3, which is a 6. The square root of k squared is a k. And left underneath the square root is a 5 and a k. And nothing else is going to combine. Number 20. Square root of x times both of these is going to be the square root of x times itself removes that radical. Square root of x times 2 is a positive square root of 2x. Multiply root 8 times both of these, negative root 8. The negative square root of 8 and the positive square root of x will be negative square root of 8x. And then the square root of 8 times square root of 2 will be a negative square root of 16, which you can go ahead and clean up if you'd like to. Now, the only thing, I know this is not going to simplify this will a little bit, so let's clean it up. So you have x. Let's bring everything else down. The square root of 8x, I'm going to split into the square root of 8 is the square root of 4 times the square root of 2, and I do not know the square root of x, so it's going to stay. So the square root of 4 is going to be a 2, and left underneath there is the 2x. So you have a minus 2 root 2x minus 4. Now these actually combine. There's a 1 right there. You have an x, 1 root 2x minus 2 root 2x's. Just combine the coefficients. 1 minus 2 is negative 1, and leave the radical. And since it's a coefficient of 1, you really don't need to put it. And then you have the minus 4. There's your final answer. The next problem says find the area and perimeter of the rectangle shown to the left. So we're looking for the area. If you don't remember to find the area of a rectangle, you multiply length times width. So 7 root 6 plus root 3 times 4 minus root 6, length times width. So let's go ahead and FOIL this out. 7 root 6 times both of these. 7 root 6 times 4 would be 28 root 6. Only multiply coefficients. 7 root 6 times negative root 6 would be a negative. 7 times 1 is 7. Root 6 times root 6 is a 6, so it would be 7 times 6. Now root 3 times both of these. Root 3 times 4 is simply 4 root 3. You can't multiply them. Root 3 times a negative root 6 will be a negative root 18. So let's see what all we can simplify. We can't break down root 6 any. 7 times 6 is 42. You cannot break down the root 3. You can break down the root 18. That's going to be the square root of 9 times the square root of 2. Now, is there anything that's going to combine? You have a root 6, a root 3, and a root 2, and no roots. So therefore, that's not going to combine at all. Next, you're asked to find the perimeter. To find the perimeter, you're going to add together all these sides. You have a 4 minus root 6 on top and a 4 minus root 6 on bottom. You have a 7 root 6 plus 3 root 3 on left side. The right side will be the exact same thing. So what we can do, instead of saying that we have 7 root 6 plus root 3 plus 7 root 6, we can just say we have 2 of them. The perimeter would be 2 of the tops, which was 4 minus root 6's. Well, because we've got to add together all the sides. 2 of the tops plus 2 of the sides, which was 7 root 6 plus root 3. Distributive property, 2 of those would be 8 minus 2 root 6 plus 14 root 6 plus 2 times root 3 is 2 root 3. Let's look for some like terms. There are some right here. So your perimeter would be 8, negative 2, and plus 14 would be a positive 12 root 6, and then plus 2 root 3. That's going to be the perimeter.